Hi guys, welcome back. This is lab number 2. Today we're going to be talking about accuracy, precision, and we're going to work all of this around the density of pennies throughout the history of the United States. I know that most of this you can go and look up right on the United States Treasury website or the U.S. Mint, but what we got to do is in this lab, we got to prove this stuff based on our lab procedures. So don't just go out and look this stuff up. The lab write-up that you've got to do has to do with our procedure, and it's going to be talking about how do we increase or ensure that we have good precision, how do we increase or ensure that we have good accuracy, and compare that with what is reality that is out there on the internet. So here we go, guys. So in this activity, we've got to figure out which year, based on the data of pennies, did the U.S. Mint change the composition of the penny? It costs money to put together this copper and this other metal that is in your lab. So we're going to take these pennies apart and we're going to start figuring out how to do this. So I'm your lab partner today, so here we go. All right, folks, so after 1 hour later of sorting pennies, I wish you guys would be here to pull your own weight. I have some pennies from 1962 to 1969. So in your lab, you've read that 1962, they changed the composition of the penny, so we know it starts there with a certain composition, but we don't know when after that they changed the composition again. So I've separated these out into the 1962 to 69, 70 to 79, and 80 to 89, 90 to 99, and 2000 to 2009. So what we're going to do then is we're going to try to narrow down what decade that they changed the composition again based on the density. And then we can go year by year once we figure out what decade might be off just a little bit. So remember, density is, well, you know what density is. So we're going to try to find the mass. Now, why would we want to find the mass first? Because the mass, when we get the mass, these are going to be dry. Because if we were to get these wet, which is how we're going to find the volume, then we would be weighing or getting the mass of the water in addition to the penny, which would definitely throw some things off. So you may want to put that into your procedure as well. So at this point, you're going to need to go ahead and get some paper, and you're going to have to start recording some of these pieces of information down when we take these measurements, because I'm not going to tell them to you. This is going to be in your lab. So before we even get to measuring the mass, I want you to take a look at some of the pennies I did not use. You can put this into your explanation at the end of the write-up, why these would not have been used in the data and how that could have affected our accuracy and the results that we get. Here we go. So using our electronic balance, we're going to go ahead and get the mass of some of these pennies. So I'm going to start with a 1962 to 1969. I'll go ahead and put that down there so you can remember that. So 1962 to 1969 pennies. Now I'm going to hit 0 on this. There's 209. So I'll take this off. It should be negative 209. 2.09, sorry. And so I'm going to only measure out 25 of these pennies. And so here's the reason why. If I just put one penny on here, okay, that doesn't seem right, does it? But it is. If we put one penny on here, that's going to be 3.07. Well, if we wait, we've got some wind in here. And so 3.07 grams per one penny. So what would happen if that penny may have been worn over time? What would have happened? So what we're going to do is not just use one penny. We're going to use as many as we can, and we're going to find out why I chose this many. Well, first of all, I only had 29 of them, and about 4 of them were a little bit, I don't know, corroded. Had some corrosion on them. but we're going to try to get as many of these as possible. Because now, when we put this on here, 25 pennies have 76.87 grams. So that's what you're going to want to write down. And then to find the individual mass of each penny, then you can divide that by 25. So yeah, we've got a little error in here. And so we're going to record that at 76.87 grams for the 25 pennies for the 1962 to 1969 set of pennies that we have. Now, if we wanted to go really, really precise, we could actually use another instrument over here. This electronic balance, this one, is going to go out a lot further. And so this is not just going to go out to the hundredths, it's going to go out to the 10,000ths of a gram. And of course this, if you just open this, the air, we have air going through this, you'll see that it is going to measure air flow at 10,000th of a gram. If we were to do that, we would definitely see a difference and we could get a better result. But we're not going to do that with this lab. Obviously, putting pennies on there would be a little rough on it. So we're not going to do that. So hopefully you got your data here. And here we go. So here we are. We're going to try to get the volume of these pennies. So to get the volume, we're going to use the volume displacement method or the change in volume method. And we can use either the 100 milliliter, the 50 milliliter, or the 10 milliliter to get the volume. And of course, we've got to just go over just a little bit about how to read the meniscus. And actually not just reading the meniscus, but actually showing the numbers. And so let's say this was our 10 milliliter graduated cylinder, and this was the volume, the little dotted line there. If we were to look at the graduations, we have the major graduations at 1 milliliter apiece, and then the minor graduations at 0.1 milliliters. So where would we measure this out to? Well, we know for a fact that if this is our meniscus, we know for a fact that it's above 9.4 and less than 9.5 milliliters. So if I am just looking at this, eyeballing this, and that is about 9.45, I can say with fairly good estimation that this is going to be a 9.46 or 9.47, give or take. And again, that last significant digit is estimated. So whenever we start looking at real meniscus here in just a second, remember, go one more digit past the known. These are known. We know it's more than 9.4. We know it's less than 9.5. So you got to go one more digit past the known graduations when you write your data. So back to our instruments that we can use. We could use the 100 milliliter graduated cylinder, or we could use the 50 milliliter graduated cylinder. Now, which one do you think we would want to use? To become more precise, we'll look at the graduations. From here to here is 10 milliliters, but from over here, it's here to here is 10 milliliters. You still have the same 1 milliliter graduations, but these are a little further apart. So that's probably going to allow us, with our eyes and our ability, to make a little bit better assumption on the closeness of our measurement. Now, why wouldn't we want to use the 10 milliliter? Well, the 10 milliliter would obviously give us a lot closer graduations, but we got a problem. How are we going to get our penny in there? It's not going to work. And so we're going to try to use our 50 milliliter simply because we know that 25 pennies will fit in there. All right. So to get to our volume of our original amount, notice the lines, they need to be kind of parallel, okay? You need to be able to see right there. See how that, then bring it together. So this one's pretty nice. I've pretty much got the meniscus right at 30.0 milliliters. So remember, we know it's more than 30, less than 31, so one more out would be 30.0 milliliters. I'm not going to give you the rest. Notice I'm trying to put this with a dark background. So if you're measuring some stuff, sometimes if you got a light background, put something behind it so you can see better. Now we're going to add the pennies and see how much it goes up. All right, so one of the things I want you to notice is whenever we drop our pennies in here, to make sure we are accurate, we don't want to be measuring the volume of air. So we want to make sure we get rid of any air bubbles that might be stuck in between our pennies. So when we do that, that's going to change our volume. Now you can't be smacking this too hard because the water will bounce out of the top. So you got to very gently make sure through your technique you get rid of as many air bubbles as possible. And part of this you can do by dropping in the pennies one at a time and making sure there's no air bubbles. So yes, it's tedious, but what does it do for your accuracy? All right, so now we started out at 30.0 milliliters. What did it go up to? Now I'm going to look in here, try to get the meniscus right there. You've got to record that. Let's try to get rid of those little bubbles there as well. Right there, right there. So you guys tell me, what is the volume of 25 pennies? Okay, so here we go, 1970 to 1979, this decade of pennies. We've got a brand new weighing boat. We're going to put in our 25 pennies. I had to make sure that my hands were dry to make sure we didn't get any extra mass in there. Okay, so this is a different mass. For 25 pennies from 1970 to 1979, you need to record that data right there. Okay, for the beginning volume, remember we're going to use this 20 here. For the beginning volume, what would you say this is to the tenths of a milliliter? Okay, after adding the 1970 decade pennies, what did the volume go up to? Again, we'll get our meniscus right in there. And so right, is that focused, I hope? There you go. What would you call that? Our next step is the 1980 to 1989 decade of pennies. And so if we would, let's go ahead and take this off. Put in 25 of these pennies. Put it back on. And here we go. This is your data for 25 of these pennies. This would make that 71.97 grams. For our beginning volume. For our beginning volume for the 1980s, what would you say your beginning volume is? We've got the 25 1980 series pennies. What would the volume, the ending volume, be now? Right there's your meniscus. Get that recorded. On to the 1990s. So we're going to go, get this, 25 of 1990s pennies. Put this back on here. Well, this is going to be odd, 62.48 for the 90s. Okay, here's the beginning. Here is the beginning meniscus. Get this over here a little bit better. Can you see that? What is the meniscus for your beginning volume for the 1990 decade of pennies? After putting in our 25 pennies from the 1990s, I'm going to try to ignore those two little bubbles right there, but what is the ending volume here? We're going to use that 40. All right. And your meniscus. Into this century, years 2000, 2009. Take this off. Put in 25 pennies. Put it back. We got one with a little bit of corrosion. 62.62 grams for 25 pennies. For the 2000s. Hopefully you can get that. Pennies. Right about there. Accuracy. What would happen if we said that we were only going to use one penny? So if we had a starting volume of this. Now remember, we know that this is if I'm looking at this, this is above 27 milliliters, but less than 28. So I'm going out 27 point something. So this is give or take 0.1 milliliters, correct? So if I only put in 1 penny, how much did that go up? So now I put my 1 penny in there, would make sure we didn't have any air bubbles. But now I've gone up 28 point something here. Right there, 28 point something. If we divided the mass by this, how much error could we incur if we only have a small amount of mass and we know that our significant digit only goes out to 0.1? Well, if I've only got just a tiny bit of change in my volume, then my percent error could be really high. So what would that do to our precision or our accuracy? You decide. Okay, so we know that somewhere in the 1980s, our density changed. Either you looked it up or our data come out that way. So to be able to prove this, whether we looked it up or not, we're going to go and get the density of the 1980, 81, 82s, there's a lot of 82s, 83, 84s, 85, 86, 87, 88, and 89 sets of pennies that we have here. It might be a little tough to get some of these in here because we only have a few pennies. So that may be a problem for accuracy and precision. So let's take a look at these so we can get our data. 1980, we only have 5 pennies, so make sure you are aware of that. And the mass for the 5 pennies for 1980 is 14.82. For 1981, I have 9 pennies. There's your mass for the 1981 pennies, and there's 9 of them, so make sure you get that divided out correctly. 1982, we have 20 pennies. So the mass of 20, 1982 pennies, 59.33. 1983, we have 7 of these pennies. 1983 is 17.59. 1984, 20.07, and there are 2, 4, 6, 8 of those pennies. And we only have 3 pennies for 1985. 7.59. 1986. We have 4 pennies there. Only 4. 1987, we have 7 pennies. 1988, we have 6 pennies for 1988. 1989, we have 9 pennies. So there's your data for the mass. Now we're going to have to get the volume for each one of these to finish up our data table and then to be able to graph all of this. 1980 volume before we add the pennies. 1980, there's a meniscus after we've added the pennies. 1981 before we add the pennies. After adding, see where we at, 1980, 1982 before adding, there's your meniscus. Let me get it over here where it's 1982 before. After. 1983 before adding the pennies. 1983 volume after adding the pennies. 1984, there's your meniscus before adding the pennies. 1984 after adding the pennies. 1985 before adding the pennies. Remember, we're not going to add very many pennies, so we could be off with our percent error on this one. So just kind of keep that in mind when we're making your data tables and your graphs. 1985, there it is. Again, there's your meniscus. We'll drop these in very carefully. Hopefully no spillage of water, no bubbles. There's 19, what am I doing? Yeah, 30. Yep, 20, okay, there it is. 1985. 1986, data before. 1986 afterwards. This is the total volume, 1986. 1987, put that on your meniscus, make that record. Record that. What are we going to get there? 88. 1988. Right there. One, 1989. So this is our beginning meniscus right there. Tell us what you got. 1989. Our total volume has gone up to, there's your 40. Get down here reading that pretty even. Right about there. Okay guys, so it's taken me about 3 hours to do this. A lot of penny sorting. Hopefully you've gotten what you need. Let me know if you didn't, what we need to add. You can put it in the comments on the YouTube, or for our class, you can put it into the Google Classroom. So good luck. I will be in touch with you, and make sure you fill out the Google Forms just as if it was a lab write-up. And after this, this one's not going to be due until after spring break. So hopefully you have a great spring break. We'll see you guys.